Today's lesson is on probability. I'm sorry I can't be there today with you guys, but please make sure you are following along and you are using the handout and filling in everything that I am filling in on mine, and making sure that you're actively listening and pausing when you need to, rewinding when you need to, if you need any extra time, or asking Mr. Mossberg if you have any questions. All right, so we're going to talk about probability. You have probably talked about probability in other years, probably starting in maybe 3rd or 4th grade. So you probably have a good idea that probability talks about the chance of something happening. When we talk about something being impossible, it has a 0% chance of happening. So it is impossible that I would be a middle schooler because I've already been a middle schooler, so that's a 0% chance of happening. If we talk about something that's certain to happen or has a 100% probability, that would be you guys being in middle school, okay? You guys are definitely middle schoolers and you're going to be middle schoolers for another year. That is a 100% chance. When we talk about an even chance, that's our 50-50 shot. So think about flipping a coin in the air. Alright, so number 1, probability describes how likely something is to happen. We can write probability in different forms. So thinking about that coin again. Alright, so you see we have the quarter at the bottom, and it has a head and it has a tail. So if I were to say what's the probability of landing on a heads, well, if we wanted to write it as a fraction, we would say how many heads are there on a quarter or a coin, 1, over how many total outcomes. There could be a head or a tail, so there are 2 outcomes. So we would write that as a half. Oops, kind of big. Okay, so you can write it as a fraction. You can also write it as a decimal. Half is 0.5. And to convert that to a percent, remember we move it over 2 times, add the 0, it would be 50%. Okay, so you can see it as any of those ways. They will specify in the problem how they want you to write it, but you will see it in any of those ways. Fraction, decimal, or percent, and they're all equal. All in between 0 and 1. Oh, I just gave you the next answer. So probability is always between 0 and 1. The closer the probability is to 1, the more likely it is that it will occur. Okay, so we have this nice little scale. 0 is impossible, 50-50 shot, like the heads and tails, and 100% is certain it's always going to happen. Okay, another way we can think of that is with the weather. If there was a 90% chance of thunderstorms, or rain, you would want to bring your umbrella. But if there's only a 30% chance that's closer to 0, then, it's not as likely that it'll happen, or it has a lower probability of happening. Some of the key words that you're going to encounter with probability, the first one is or. Okay, so when you see that word or, that signals you to add the events together. Today we will use or, but we will not use and. However, I want you to know what and indicates. And means you want to multiply the events together. Okay, and we'll talk about and with compound probability and independent and dependent on Monday. So you don't really need to worry about and right now. Alright, so moving on to number 4. How do we know what to write in our fractions? Well, when they ask just for the probability of something, we are going to use this formula. Okay, so we're going to say that this little bar here in number 4 is a fraction, and on the numerator we're going to say the number of favorable events. And you can pause it if you need more time to write. Over the number of possible events. Or, excuse me, possible outcomes. Okay, so we're going to use that setup, number of favorable events. Favorable just means what's the question asking for. And then number of possible outcomes, how many marbles are in a jar, how many, heads and tails, so there's always 2 possible outcomes. If it's a dice, there's always 6 possible outcomes. Okay, so we're going to look at number 5. And I want to reiterate what is in bold. Remember to always reduce or write fractions in simplest form. Very important. All right. Now, it says, in a jar of 40 marbles, there are 12 blue, 14 pink, 8 red, and 6 yellow. All right, we're looking for the probability of certain events. Okay, so we've taken the word probability away and we just replaced it with a P, and we're looking for this event of pulling a red out of the jar. Okay, so let's look back at our little setup, number of favorable events. Okay, so we would say how many red, because that's what the question is asking for, how many red are in that jar? Okay, well, we look up and we say, oh, there's 8 red. So we'd say 8 over how many possible outcomes, how many possible things are in the jar, how many marbles are in the jar. There are 40 marbles in the jar. Okay, is that reduced? No, it's not. So take 15 seconds, think of what that can be reduced by. All right, and hopefully you have decided that it can be reduced by 4. Okay, so if we divide by 4, on the numerator we get 2, on the denominator we would get 10, and look, it can still be reduced. Okay, so you could have reduced it by 8 or 2. And this time we'll reduce it again by 2 and we get 1/5. Okay, so that's my probability as a fraction of picking a red out. As a decimal, 1/5 is 0.5, and remember we just move it 2 times over to get the percent. So, oops. Alright, hopefully you have a eraser, because I was definitely going too fast and I said that 1/5 was 0.5. See, we all make mistakes. I quickly caught that. It's 0.2, which is 20%. Sorry about that, guys. Careless error. Alright, moving on to the probability of picking a pink. Okay, so how many pink are in the jar? There's 14 pink in the jar. How many total marbles? There's 40 total marbles. Alright, so what can we divide by? Think about it for a second. So you can divide by 2. So if I divide the top by the numerator by 2, I get 7. And if I divide the denominator, 40, by 2, I'm going to get 20. So 7/20ths. 7/20ths, go ahead and put that in your calculator, see what 7 divided by 20 is. You should get 0.35, and then as a percent, 35%. Got that one right this time. Alright, the next one says probability of picking a pink or a blue. So when we see that word or, we know we are going to add. Alright, so we're going to add pink and blue. How many pink do we have? 12. How many blue do we have? Oh, I'm sorry. We have 12 blue and we have 14 pink. There we go. Okay, so we add up the 2 and we should get 26 pink or blue over 40. Okay, think to yourself, what can I reduce that by? They're both even, so I can divide by 2, so let's see if we can do that. So if I divide 26 by 2, I'm going to get 13. And if I divide 40 divided by 2, I'm going to get 20. 13 over 20 is 0.65, which is 65%. And that last one, which might cause a little bit of confusion, it says the probability of not picking blue or yellow. So you can look at this 2 ways. You could start with 40 marbles and subtract blue and subtract yellow, or you could look at what's left. Well, we're not going to look at blue and we're not going to look at yellow, so we're going to look at pink and red. So pink is 14 and red is 8. Okay, so those are the marbles that are not blue or yellow. So 14 plus 8, we'd get 22 over still 40 total marbles in that bag, in that jar. And if I divide by 2 again, I'm going to get 11 over 20. 11 over 20. That cannot be reduced any further. 11 is what we call a prime number. So you would say it's 0 point, and you can divide it in your calculator, 55, which is 55%. Okay, pause if you need to fill anything else in or if you have any questions. Otherwise, you can keep on going to number 7. Okay, so hopefully by the end of the week you have a pretty good grasp of the difference between theoretical probability and experimental probability. So if you think back to number 5, we were talking about the probability of picking one marble picking one marble out and seeing what's the probability of it being red or pink or blue. That we didn't actually conduct an experiment, okay? So we would consider that theoretical probability. All that means is in theory, right? It's a hypothesis. It's what should happen in a perfect world, but it doesn't always happen. We haven't conducted an experiment, but it's in theory. So you see that root word theory in theoretical. So theoretical probability is the probability of what should happen. And again, what is expected? Anytime you see that word expected, what is the expected outcome? You want to think theoretical. Very, very important. Okay, so is number of favorable outcomes over the number of possible outcomes. So same thing here as regular probability. When it doesn't specify, we can assume it's talking about, in theory, what should happen. All right, so here we go for number 8, back to the dice. What is the theoretical probability of flipping a heads on one coin toss? So you want to ask yourself, how many heads are there, right? Because when we talk about how many heads, that's the favorable outcome. That's what they're asking for. They're asking for heads in the problem. So there's one head on a coin. And how many possible outcomes are there? Well, there's a head and there's a tail. So there's 2 possible outcomes, and half is 50%. Okay, now we see that word expected. What would the expected result be if you flip a coin 100 times? Okay, so we want to think about 100. And if it's 50-50, what's expected, how many times would I flip the coin, or how many times would it land on a head, and how many times would it land on a tail? Well, it's going to land 50 times on heads and 50 times on tails. Now, that's actually not accurate. Well, it could be accurate, but it probably won't be. You'd probably get something around mid-40s and maybe mid-60s or so, but if we were being asked what would be the expected result, we would say 50-50, okay? Number 9, if you randomly choose one of the letters shown in the word explore, what is the theoretical probability of choosing a consonant? So their question is asking for choosing a consonant, so that's my favorable outcomes. So we would say number of consonants over number of possible outcomes. So how many total letters there are in that word. Okay, so we'll have a little English lesson real quick. How many consonants are in this word? So remember, vowels are A, E, I, O, or U. So then we're left with all of the other letters being consonants. So X, P, L, and R are consonants. So how many consonants do we have? We have 4 over the total number of letters, which is 7. So the probability of picking a consonant out of the bag or from this word is 4 out of 7. And that cannot be reduced. All right, on the back, I want you to try this. Use the picture here because you can't really see the colors on yours. But I want you to try to figure out what the theoretical probability of each of spinning a red, so the first one, probability of spinning a red. Second one, probability of spinning a 1. Probability of spinning an odd number. And the probability of spinning a number less than 7 is. So please pause the video right now and go ahead and try to solve those 4 in fraction form and make sure they are reduced. All right, go ahead. Okay, so I hope you definitely paused the video and got some answers for these probability questions. All right, so in theory, if we were to spin a red, well, you say how many reds are there on that spinner? There are 2 reds, and how many total numbers? 6. That can be reduced to 1/3. All right, looking at 1, probability of spinning a 1. How many 1s are on the spinner? Well, there's only 1 1 on the spinner, so that's the number of favorable events. And then how many numbers are on the spinner? 6. So 1 6. C, spinning an odd number. Well, 1 is an odd number, 3 is an odd number, and 5 is an odd number. So I have 3 odd numbers on that spinner out of 6, which is half. And probability of spinning a number less than 7, well, all of the numbers are less than 7, so I would say 6 out of 6, which is just 1. Okay, so now we've talked about theoretical probability. In theory, what should happen? Experimental probability, you see that keyword experiment. That's what actually happens, okay? So we're going to conduct an experiment, or the question is going to give you data or some type of results so that you can note what the experimental probability is. All right, so please go ahead and fill in the experimental probability format. So we have number of times the desired outcome occurs, which is on the numerator, divided by the total number of, or the number of total trials. All right, so in number 12, we're going to look at this data in the graph because it says we're looking for experimental probability, okay? Question 12, you roll a number cube 50 times. 50 times tells me that's the number of total trials, so it's going to be on my denominator. Okay, the results are on the right. What is the experimental probability of rolling a 5? Okay, so let's think about our fraction. We have the number of times the desired outcome occurs. What is the desired outcome in this question? Well, rolling a 5. That's what they want to know. So how many times was a 5 rolled? We follow up the graph and we look to the left, and it occurred 8 times. All right? So we would say 8 over how many total trials? Well, 50. We flipped that, we rolled that dice 50 times. Okay, 8 over 50. That can be reduced. Uh, 8 over 50 can be reduced to 4 over 25, which is 16%. Okay? So make sure you understand that one. If you need to listen to it again, you can. I'm going to erase it so there's enough room for the next problem. Okay, this time it says experimental probability of an odd number. All right, so we know we have 1, 3, and 5 are our odd numbers on the dice. In 1, we got 10. We rolled a 1 10 times. We rolled a 3 8 times. And we rolled a 5 8 times. So you're going to add up the 3. 10 plus 8 plus 8. And that would be 26. So the number of times the desired outcome, or what the question asks for, an odd number, occurs is 26. And we still have 50 trials. That can be reduced. And you get 13 over 25. Go ahead and put that in your calculator. Divide 13 divided by 25. You should get 52%. Okay, so that is experimental probability. We use the data or some type of results in order to get our probability. Note that on 14 and 15, we're not looking for experimental probability, so do not use the data anymore because it says theoretical probability. So what is the theoretical probability? You have a dice of rolling a 5. A dice has how many 5s? How many favorable events or outcomes? How many 5s? It has 1 5. And how many total outcomes are there? Well, there's 6 because the dice has 6 numbers on it. Okay, so 1 6 is 16.6 repeating percent. How about the theoretical probability of landing an odd number? Well, on this dice, we have 1, 3, and 5. Those are our odd numbers. 2, 4, and 6 are our even. So we have 3 odd numbers out of 6, 1, 2, 3, 4, 5, 6, 6 options, which is half, and half is 50%. So theoretical probability, in theory, what's expected. Experimental probability, what actually happened. You're using results from a graph or from a chart or some type of results that they give you. Okay, the next part is for you to try. So I want you to answer these 3 questions before conducting the experiment at your table. I want you to answer number 1, it's theoretical probability. Number 2, theoretical probability. And then 3, I'll really quick go over. This is what must we do in order to find the experimental probability. all I want you to think about is if you don't get any data, there wasn't an experiment conducted. So in order to find the experimental probability, you actually have to conduct some type of experiment. Okay. All right, make sure you listen carefully for your next instructions. So once you've done 1 and 2, Mr. Mossberg will be checking those, but he's going to check those once you've done 1, 2, 3, the table, and number 4. Okay, so what I want you to do is raise your hand right now. Mr. Mossberg will hopefully come over and give you a dice. Okay, raise your hand and he's going to give you a dice. And you might want to pause the video. Once you have your dice, you're going to end up rolling that dice 20 times, okay? So, say on my first roll, I get a 4. I'm going to put a tally mark in next to the 4. Then, pretend I get a 3. I'm going to put a tally mark in the 3. Then say I get a 1. I'm going to put a tally mark in the 1. You should not be putting tally marks because you have not actually rolled your dice. I want you to do this on your own, okay? So once I have rolled 20 different times, so let's say I got 3 there, 5, 8, okay. So say I have all 20 of my tallies. What I'm going to do is I'm going to total them out. So this one has 3, this one has 3, this one has 5, and so forth. Okay, I'm going to total them out, and then I'm going to answer number 4. Number 4 says, what is the experimental probability of landing on a 6? So that comes straight from your data. Okay. Think about how you rate experimental probability. So the number of desired outcomes, how many times that happened, over the total number of trials. You do not need to worry about number 5 and this little graph that was going to be if I was at school today. So just do number 4. Once you answer number 1, 2, 3, you have your little graph done, your chart, and then number 4, you can either go up to Mr. Mossberg and ask him to check it, or you can raise your hand and ask him to check it, okay? If there's any part of the video you need to see again, please rewind there, but I hope this was easy enough for you to walk through with me, and good luck on your reflection. I look forward to seeing you guys on Friday. All right, have a great day. Please be good. Bye.